Hi, everybody. It's Mrs. Cassill. I'm here to talk to you about types of forces. This is a really brief summary of something we would have covered in class, but it's a point that I want to make very clear. All right. So, are all forces the same? What makes them similar or different? So, first thing I want to say is there's a adorable Veritasium video, misconceptions about falling objects. There's a blonde girl in it that drives me crazy. I'll link it as an extra credit assignment for discussion. But there's some things that are really great in this video that get to this point about force and acceleration. So here's the thing you need to know about forces. They come in two flavors, for lack of a better word. There's contact forces and field forces. Contact forces are exactly what they sound like. They result from direct contact between two objects. So two objects touching one another exert forces on one another. You high five somebody, that was a contact force that you each experienced. A field force is a force that can act at a distance. So you can attempt to high five the moon and you do not contact the moon. It be far away. However, there is a gravitational force between you and the moon because the moon has mass and you have mass. We'll learn more about how that all works in a later unit. But those are the two flavors of forces. So in class, we would have done this, and we're not doing this right now. And I want to just sort of, you'll see these examples, and I think it'll be self-explanatory as we go. But when you look at a story problem that's got a force in it, first, the force's name is just labeling where the force came from. It's a force. All forces, I should go back to this, contact forces or field forces do the same thing. They accelerate objects. They change the state of motion or can change the state of motion of an object. What is an object? Something with mass. So what do forces do? Forces accelerate masses. Congratulations, you've learned like 90% of physics. So, regardless of what a force is or what the label might be that you put on it, there's a couple things you have to ask yourself every time to make sure you really are understanding where it's coming from and what it's going to do. So, ask yourself, is it a contact force or a field force? Because that might change how you calculate or where you apply it in a free body diagram. You need to come up with a way to abbreviate your force. It changed my life in college when I realized instead of whatever subscript my textbook or my professor had used, I could put words down there. I told you, what did I want to be when I grew up? I wanted to be a writer. I love language. Language makes sense to me. And so instead of having F12 and F21 as labels for forces, it helped me so much to write things like force hand, force wall. So figure out how you're going to abbreviate your force. It's always a capital F with a subscript, either a single letter or a word that's describing the origin of that force. So then we label forces on a free body diagram using those abbreviations. We would have done that in class. But here's a couple of the big ideas that we would come up with in class. And I want to show you some other examples from STEM physics that will appear also. So we'll often have an applied force. You'll hear that in a story problem. So that's anything from the outside. If you push or pull something, if you, throw a yoga ball at somebody and the yoga ball collides with them, it's applying a force. So you could call that applied force, or I like to label it with the source so it makes sense. F push, F ball, F explosion. All right, so I understand for the storytelling aspect of the scenario where that force came from. The normal force, or force normal. So that force is always perpendicular to your surface. It is always abbreviated capital F with a subscript capital N. You'll see it all the time. Air resistance, we're going to ignore it almost all of the time. So you're not going to see it appear very often. Electrical force, magnetic force, those were examples. I want to pull up a couple others that, in STEM physics, we tease out the list a little more, but you'll see these kinds of things appear as well, right? Force of gravity is always a capital F with a little g down below. Force of friction, capital F, and usually a little f for the subscript. Tension, Tension we'll learn more about in some later problems here. Tension is just pull or, that's occurring through a rope or flexible fiber. So some sources will abbreviate it with a capital T. Why complicate your life by changing the letter? Tension is a force. Label it a capital F with subscript capital T for tension. There's spring forces, there are electrical forces, there are magnetic forces. You can imagine labels for these. There's all sorts of ways that you might depict those, right? All of them are going to be a capital F with some sort of subscript. Okay. I believe that's all I wanted to cover. We would have done a gallery walk and go around those stations, but I wanted to go over that idea here and this notion that forces come in two flavors. All right. Thanks, everybody. Keep learning.